Hello, guys. So thanks for joining us once again. Here we are once again, and this time around we are getting you the hottest. And in fact, you are going to love this one. It's about the TensorFlow.js, and we have Jason Myers here, and you guys know Jason Myers. It's really good. It's very good in TensorFlow. Jason Myers has had a whole lot of great events, especially at Google I/O and others. And I would like to invite Francis. Francis, that's the DSC KNUSD lead, to just do the introduction whilst we prepare, then Jason Myers take over. So guys, stick with us and drop your comments as well. And I will also put the link in here. If you have any question for Jason, you can just drop it out for him as well. So let me invite Francis, and let's hear from Francis. Yeah, so welcome, Francis. Yes, so this is Francis from KNUSD. He is currently the DSC lead there. And we have Hannah. Welcome, Hannah. Hannah is also the DSC lead for HSE. Hi, Hannah. And we have Emmanuel. Emmanuel is currently offline. And we have Elvis. So we are about 6 in Ghana here currently. So Francis, I will leave everything in your hands now. So you take over. Yeah, thank you very much.
Okay, so once again, hello everyone, and as Shadrach said, my name is Francis Shannon. I'm the DS lead for Kwame Nkrumah University of Science and Technology in Ghana. So over a couple of weeks ago, we've been working on these sessions where we have online workshops. We introduce people to new technologies. We introduce them to how to get started and everything. So today we have a very special guest, and he's going to actually lecture us or teach us on what we need to know about TensorFlow.js. And if anyone here doesn't know TensorFlow.js, TensorFlow.js is actually a JavaScript library for training and deploying machine learning models in a browser. Then you definitely need TensorFlow.js because it's just great. So we have in our midst Jason Myers, and he's going to handle everything for us. And also, as Shadrach said, we have Hannah, we have Elvis, we have Emmanuel, and we have Jesse. And we are all DSC leads in Ghana, and we are here to help anyone at all who wants to just get started in TensorFlow. Also, when we are done with everything here, we're going to actually send you guys a link where you can actually ask questions. If you want to get to know more, or you want to even just connect with any of us, you can just give us a hi on Twitter, on LinkedIn, or even email, and we'll be glad to help everyone.
Sure. So I'm getting Jason Myers in. So he will just introduce himself to us, then he can take the wheel from there. Yeah, so.
Cool.
Hi, Jason.
Hi there. Thank you for having me today on the show. Good to meet you all. I'm going to go ahead and start presenting my screen so the slides are up. One moment.
All right, sure.
All right. Hopefully you can see the slides. Yeah. Okay, perfect. So hi everyone, I'm Jason Mays. I am the developer advocate for TensorFlow.js at Google. And basically what that means is that if you're using machine learning anywhere in the world using JavaScript, there's a good chance our paths will cross at some point. And I often get asked a little bit about my background and how I ended up in this position at Google. So I'm just going to very quickly talk about my career path to date. I started off as a computer scientist at the University of Bristol in England. I'm actually from England originally. And I then joined many startups as a web engineer. And I learned about front-end technologies, back-end, design, UX, all this kind of stuff, which led me to become a full-stack web engineer at Google. After that, I transitioned into creative engineering, which allowed me to create prototypes for Google's top 100, 150 customers around the world. And this allowed me to essentially combine all my web engineering skills with my curiosity for emerging technologies, things like machine learning, augmented reality, and everything else in between. And you can see some of the bits and pieces I've been creating over the years here in these animations. And then finally, just under a year ago, I joined the TensorFlow.js team as their developer advocate, which essentially allowed me to combine my love for JavaScript and my love for machine learning in one team. And if there's one thing you take away from this slide, it's that I basically spent almost over half my life using JavaScript. So I'm a big fan of JavaScript, and I'd like to share with you today why this is an important language to learn and how powerful it can be. So the question next is, of course, like, why do we want to do machine learning in JavaScript? And this is a great question. And essentially, it allows us to use machine learning anywhere that JavaScript can run. And that means it can run in the web browser, on the server side, on desktop native, on mobile native, and even on Internet of Things. And if we dive into each one of these stacks a little more, you can see many of the browser and other technologies that you might be familiar with already. So we've got the common web browsers on the left-hand side here, Node.js, React Native, WeChat, progressive web apps, Electron for desktop native, and even Raspberry Pi, because you can actually install Node.js on Raspberry Pi, and that means we can run on there as well. And on that point, JavaScript is the only language that can run across all of these devices without any additional plugins or anything else. So very, very powerful just for this reason alone. And TensorFlow.js allows you to run, retrain via transfer learning, or write your own machine learning models completely from scratch if you so desire. And if any of you are familiar with Python TensorFlow, which is the original TensorFlow that came out many years ago, it's very similar to that, except it's in JavaScript. So anything you're used to be able to doing in Python TensorFlow, you can also do in TensorFlow.js. And this can be used, of course, to make anything you dream up, from augmented reality, sound recognition, sentiment analysis to understand natural language and all this kind of stuff, conversational AI, and much, much more. And we're going to go through a few interesting use cases today that people have made. So there's 3 ways you can use TensorFlow.js. Essentially, depending on your skill level with machine learning or your skill level with JavaScript, you might choose one over the other. But I'm going to go through those 3 ways right now. Now, the first one is to use our pre-trained models. These are really easy to use JavaScript classes for many common use cases. And you can see some of those use cases here today. Things like object detection, body segmentation that allows you to understand where the human body is in an image, pose estimation to understand the pose of the person in the image, and many more you can see on the slides. So I just want to dive into some of these to show you how they work. So the first one, object recognition. This is actually using a model known as COCO-SSD behind the scenes, just a very fancy name for a object recognition model. And essentially, this has been trained on 90 object classes. And what that means is that out of the box, you can recognize 90 common objects, things like dogs, cats, humans, a mobile phone, things that you might have around in your house or in your hands. And that means we can get this bounding box information of those objects if we can see them in the image, as you can see with the dogs on the right-hand side here. So not only do you know that the dog is in the image, you know where in the image the dog is. And that can be very, very powerful. And that's different to image recognition, which is just saying that we can know there's a dog somewhere in the image, but we don't know where. So object recognition gives you the bounding box as well. And that's the difference between object recognition versus image recognition. So let's go ahead and show you the demo of this in action. So I'm just going to switch to my other tab, one moment. Share my screen again. And where is it? Here we go. Share. There we go. So hopefully now you can see my screen. And this is a piece of code I wrote over on glitch.com. And this is running live in my web browser right now. And if I click on one of these images, I'm using TensorFlow.js COCO-SSD to highlight the things in these images that it can find. And you can see here, it's found this rather naughty dog trying to eat the treats on the table. So you can imagine how you could use this technology to actually do very useful things. With this kind of technology, you could make your own version of a Google Nest webcam that can tell you when it's seen a person enter a room, or if your dog is in the kitchen or something like this. You could easily detect these kinds of things. And even better, this can run live in the webcam. And if I enable my webcam down below, you can see me in my room right now, and it's detecting me as a person with 92% confidence, which is a good score. So obviously you get the confidence score coming back as well, and that allows you to make a decision as a developer if you want to do something or not. If it's low confidence, maybe it's not good enough to do something at that point. But notice how fast this is running as I'm talking to you right now in real time. And this is running live in the web browser and is super speedy and can be used in real time like this. So JavaScript is very, very powerful, and it can do many things with this with a bit of creativity. So I'm just going to go back to my slides, one moment. There we go. Cool. So back to the slides. Next up, we have face mesh. This is just 3 megabytes in size, and it allows you to recognize 468 facial landmarks on the human face, as you can see from this animation on the left-hand side. Now, this can be very powerful for many things, but one example use case is by Modiface, who's part of a L'Oreal group, which you may have heard of. And this company has used face mesh to create a system that allows you to try on makeup in augmented reality, as you can see on the right-hand side. So this lady is not actually wearing any lipstick. We are actually rendering this lipstick to her face using 3D graphics. Because we know this makeup of the face on the left-hand side, we can now draw things on top of it. And she can change the shades of lipstick she's wearing to understand what she might look like with different types of lipstick before she even purchases the lipstick. So this is very powerful, and I'm just going to show you a demo of face mesh in action because it's really very interesting to see how far you can push this. So once again, I'm just going to stop presenting this tab, and I'm going to go over to my second demo. One moment. Where is it? Here we go. And now you can see me again live in the web browser with the face mesh being applied to my face. And as I open and close my mouth, you can see that updating in real time on the left-hand side here. Now, because JavaScript has been designed from day one for the presentation of content and information, we can also do some 3D graphics. And on the right-hand side here, you can see I've got a 3D point cloud of my face being rendered in real time, in addition to the machine learning happening on the left-hand side here. So you can see how powerful this is, and it's running even with both of these things going on and me live streaming to you right now. There's many things going on with my computer. Even then, I'm getting 23 frames per second or so, which is really very impressive. Now, notice this is actually running within something called WASM on the top right here. WASM stands for WebAssembly, and this just means that we're executing on the computer processor. If we switch to WebGL, it will then leverage the graphics card of the machine, and we would see even higher frames per second. When I've tried this in the past, this can go up to 45, 50 frames per second if we're using a modern graphics card. I'm not going to do that right now because I'm live streaming, so I'm using my graphics card for live streaming, but you would see a performance improvement if you were not live streaming at the same time. So very, very powerful, and this just shows that JavaScript is not a toy language. It's actually very powerful and can be used for real-time applications like this in the browser. And what's really cool is that my privacy is preserved. At no point are any of the images from my webcam going to a third-party server. And this is great because in the world we live in today, privacy is top of mind for many people, especially if you're trying to do medical applications or anything legal related. And in some countries, maybe you have poor internet connectivity as well. This can run offline. And that means even if you're in the middle of a field, you can have these technologies working in your web browser offline using something like progressive web apps or something like this. So I'm going to go back to the presentation, one moment. Where's my presentation? Oh, okay, perfect. So face mesh is, oh, sorry, I've just talked about, yeah, face mesh is a great tool for understanding everything you could want to know about your face. So the next one I want to talk about is body segmentation. Essentially, this allows you to distinguish 24 body areas across multiple bodies, all in real time, live in the web browser. And it's hard for me to demonstrate this today, so I've got this animation instead. But you can see these 3 people in the room moving around, and we're able to color their arms and legs and chest and head in different colors to show that we can identify what each part is correctly. And you can even see that there are some lines where we're drawing where we estimate their skeleton to be. So then from that, we can estimate their pose, and you could actually create fairly easily something to detect pose or gesture or something like this, which could be very fun to experiment with. And of course, if you take any of these models, you can use them in really delightful ways. And here are just two examples I've created in my spare time that illustrate this. On the left-hand side, I've made an invisibility cloak, much like in Harry Potter. And you can see as I get on the bed deforms in the middle image, even though I'm removed from the webcam in real time, turning myself into a ghost live on a webcam stream. But notice how the bed still deforms. So this is still a very advanced effect. And then on the right-hand side, I don't know about you, but I'm very bad at understanding what size clothes I need to order when I'm trying to order new clothing. And here I developed a system that in under 15 seconds can estimate my body size, and it can tell me what size clothing I should take from the online store, small, medium, large, or so on and so forth. And that means I can get my clothes in the right size the first time instead of having to waste money sending it back and requesting a different size. And both of these demos were created in just a couple of days. And that really goes to show the power of JavaScript for prototyping. And it's very powerful for this kind of stuff. In other languages, this might take you a week to create because the libraries are not so mature for computer graphics and other things like this, accessing the webcam, all this kind of stuff. The presentation of all that rich data could take much more code in other languages. And of course, this can even be used to give you superpowers, as you can see here. This is made by one of our community members over in the USA, and he has combined TensorFlow.js with WebGL shaders. And you can see here how he can create this really cool 3D graphics effect, much like the movies, like Iron Man, where he can basically shoot these lasers from his eyes and mouth in real time. And this is a fun effect, but you can imagine if you were working in, say, the movie industry or some creative industry, you can make something really fun and creative on the web for people to try. And you can even go and combine this with other technologies. In fact, this guy from France, also from our community, used the body pics model that we were just speaking about so that he can scan any magazine. And if there's a body in that magazine, he can bring that body to life and position the body in his living space. And notice that this is actually running on a mobile device. This is running on his Android mobile phone from 2 years ago. It's not a modern Android phone either. Yet he's able to achieve these really lovely 3D graphics and the ability to recognize the body from the image all in real time. And I thought, well, if we can do this kind of stuff, why not take it one step further? And here's another prototype I created where I'm able to teleport myself anywhere in the world. You can see in step 1, I'm in my bedroom. In step 2, I use the body pics model to segment myself from my bedroom. And then in step 3, I can use WebRTC, which is real-time communication, combined with WebXR, which is mixed reality, all in JavaScript in the web browser to then place myself in a physical space somewhere else. And that allows me to talk to the person as if I really were there with them in their space. And they can walk up to me, they can walk around me, they can hear me from different directions, and so on and so forth. So it's a much more immersive experience when we're all stuck at home working from home. It feels like you're connected to people just a little bit more than a rectangle on the screen. Now, the second way you might want to use TensorFlow.js is for transfer learning. Now, once you've used our pre-trained models, you might want to know how you can use these to work with your own custom data. And there's a number of ways you can do this. If you are already familiar with machine learning, you can code this yourself completely from scratch. But today I want to show you 2 easier ways to use transfer learning. So the first one is Teachable Machine. This is a really easy to use website that Google created that allows you to train new machine learning models live in your web browser. And the best way to explain this to you is to show you. So I'm going to share my other screen to show you Teachable Machine in action. So one moment whilst I set that up. Here we go. So now you can see Teachable Machine. If you go to teachablemachine.withgoogle.com, you'll get to a page like this. And it essentially allows you to choose from 3 things right now. I'm sure this will grow with time, more coming soon here. But right now we can recognize objects, we can recognize audio, and we can recognize poses. So let's go ahead and click on images for today's demonstration. And you can see we're now presented with a new screen that looks like this. And you've got a number of classes on the left-hand side. These are the things you want to recognize. And you can add more than 2 classes if you wish by adding add class at the bottom here. But for today, we're just going to use 2 classes. So let's go ahead and name these things something more meaningful. So I'm going to put the first one as Jason, myself. And I'm going to click on webcam. And you can now see a live preview of what I'm seeing from my webcam. And all I'm going to do is click on this hold to record button to get a few images of myself from different angles. So here we go. I'm just going to move my head around. And you can see I've got about 34 images sampled now on the right-hand side here. And now I'm going to go to class 2. I'm going to call this cards, as I've got a deck of playing cards in my room. I'm going to do the same thing for this one here as well. But instead of using my face, I'm going to show the deck of cards to the computer like so. And again, I'm going to record roughly the same number of images. So notice I've got 42 images, a few more, but roughly the same as 34. And it's important to have roughly the same number of images to avoid any bias in the machine learning model, thinking one thing is more likely than the other. But when you've got the training data, all you need to do is click Train Model. Now what's going to happen is live in the web browser, it's going to go ahead and retrain the existing machine learning model's top layers to try and understand the data that we've just presented to it. And you can see in less than 30 seconds, we've now got a live preview on the right-hand side that tries to predict what it's seeing in real time. So we've now just trained a machine learning model. You can see down here, it says Jason with 100% confidence. It's very sure that it's looking at Jason right now, which is correct. And if I bring the deck of cards, you can see it changes to cards. So Jason, cards, Jason, cards. And look how fast that is. In just a couple of minutes, we've managed to train a custom machine learning model to do something useful that is meaningful to us. And it works really nicely on this very small data set right now. Of course, if you wanted to be more robust, you'd need more training data. So maybe if I had a green card, it might get confused. It might have only learned to recognize blue cards from that 30 samples. So if you wanted to recognize other types of cards, you need to show other types of cards as well for it to understand that other things exist. But if this is good enough for your needs, you can simply click on Export Model here, and you can download this model to then use on your website. And of course, with that, you can just copy and paste this example code, and you can be up and running in minutes. And you can then add your own user interface, and you can make that machine learning do something useful. So maybe in the case of a Nest webcam, if you detect a person, you can then send yourself a text message via some other API or something like this in order to then alert yourself that someone has been seen on the webcam or whatever you so desire. So that's Teachable Machine, and it's really great for prototyping really fast. So I'm going to stop that and go back to the slides again. 1 moment. Share screen. Chrome tab, there we go. Okay, so back to the slides. So yeah, Teachable Machine is great for prototypes. But what if you want to make production quality models, things that you want to deploy at scale? For that, you can actually use our cloud system called Cloud AutoML. And this supports exporting to TensorFlow.js as well. So here you can see an example where someone was trying to understand how to classify many different types of flowers. This could be other stuff if you wanted, but in this use case, we're going to look at flowers. And essentially, all they've done is it uploaded like lots of different folders of different types of flowers to cloud storage. And they then can have the option to train on that data with Cloud AutoML, as you can see on this screen. And essentially, you can choose if you want to have a higher accuracy, so more precision on understanding what's in the image, or faster predictions. So maybe we're more concerned on having this running in real time. So you can kind of trade off between these two things as you see fit, or somewhere in the middle. You then simply set a budget. This does cost money to use, but you can set whatever budget is comfortable for you, and then you can click on Continue, and you'll wait a few hours, and it will go and try many different machine learning models with many different hyperparameters to find the best combination that works with your training data. And after that set time, it'll come back to you and say, hey, here's what I found. you can now download this in the various formats we support, and one of them is TensorFlow.js, as you see on the right-hand side here. You just click on that button, and you get the option to download the resulting files, which contain a JSON file and some binary files. And those you can simply host on your website, and then you can use them on your website. And you might be wondering, well, how hard is it to use this kind of stuff? And I just want to show you the code to do this, because it's really easy. In fact, it's so easy, it fits on one slide. So let's just look at this. This is a combination of some HTML and some JavaScript. And at the top here, all we're doing is we're importing the libraries that we need to use. So these script tags at the top, the first one is importing the TensorFlow.js library. The second one is importing the AutoML library that we were just talking about. And then on the third line here, we have a new image that we're trying to classify. This is going to be a daisy flower, but I've just got a random image from the internet here called daisy.jpg. This could be any image. It could even be imagery from the webcam, as I've shown you before. But for the purpose of this slide, I've just made it an image tag here. So what we need to do in just 3 lines of JavaScript down below, the first thing we need to do is load the model that we trained from Cloud AutoML. And as I said, you just download a bunch of files once it's completed, and one of them is this thing called model.json. So you just pass the reference to where that is hosted on your website and call tf.automl.load image classification with the path to that JSON file. And because this is an asynchronous operation, meaning that it will take some time to download, it doesn't happen instantly, we have to use this await keyword. And this means we're telling JavaScript to wait for that to complete. And when it's ready, please assign this to this constant called model on the left-hand side here. The next line, we simply grab a reference to the daisy image that we want to be able to classify. And this is something we want to test. So we're just getting get element by ID and daisy to grab this daisy ID from above. And that's assigned to this constant called image. And then the third line here is where the magic happens. All we're doing here is calling model.classify from the model we loaded before. And we pass to it the image we want to classify, which in our case is this daisy image. And once again, this is an asynchronous operation, meaning it will take a little bit of time to execute. So we use the await keyword to force JavaScript to wait for that to finish. And then we'll have a JSON object come back in our predictions constant here on the left-hand side. So in that object, it will have all the predictions that it thinks it's seen for the image you pass to it, with the confidence levels and all that kind of stuff. And with that, as a developer, you can then decide if you want to do something or not, knowing what it has seen. So very easy to use, and just a few lines of code, you're able to pull this off very, very fast. And then the third way to use TensorFlow.js, of course, is to write your own code from scratch. This is for more of the advanced engineers out there who are already using machine learning, maybe in Python. But the essential thing to know is that you can do the same things in JavaScript. So I'm going to focus on the superpowers and performance benefits of why you might want to choose JavaScript over other languages. So first up, let's just talk about how TensorFlow.js is actually formatted. So essentially, we have 2 APIs available. There's a high-level API known as the layers API. And this is very similar to Keras if you're familiar with Python. In fact, if you know how to use Keras, the API in JavaScript is almost exactly the same. So you can be very at home with our layers API. We also have a low-level ops API, which is much more mathematical. And this allows you to do things like the linear algebra, the low-level building blocks of the machine learning, and it allows you to tweak those if you so desire. And this is more like the original TensorFlow API that first came out. And you can see how this all comes together like this. So we have our pre-made models that we saw earlier in the presentation, and they sit upon the layers API, which is this nice high-level abstraction. And then this layers API sits above the core or ops API. Now, this lower-level API then understands how to execute in different environments, such as the client side, as you see on the left-hand side here, things like the web browser, things like WeChat or React Native, this kind of stuff. And each one of these environments understands how to talk to different backends. And a backend is simply just a different hardware environment. And in TensorFlow.js, we always have the CPU available, but this is the slowest form of execution. If you have a graphics card, we can use WebGL in the web browser to use the graphics card. And as I mentioned before, we also have WASM, or WebAssembly, to execute slightly faster on the CPU. So as a developer, you can choose which environment you want to execute on. And if you don't specify, if TensorFlow.js realizes you have a graphics card and support for WebGL, it will automatically try and use that as well. So that's pretty cool. And this stack here you see on the left is only for the client side. That means when you're running in the web browser. On the right-hand side, you can see the server-side implementation where you can use Node.js, because this is also JavaScript. You can use Node.js on the server side. And on that, you can actually execute on both the CPU and GPU as well, just like you can do in Python-based TensorFlow. In fact, it talks to exactly the same C++ APIs behind the scenes. So you get the same acceleration as Python does for the CPU and for the GPU. So it's talking to the same CUDA stuff for NVIDIA behind the scenes, which is pretty awesome. And we'll see how there's almost no difference in inference time later on in the presentation. The last point I want to end with here is that if you are wanting to continue to use Python for your machine learning development, that's completely fine too. But if you want to integrate with a web team, you can actually take your Keras model from Python and you can import it via the layers API in Node.js. And if you have a TensorFlow saved model, which is the lower level format model, you can import it via our ops API, also in Node.js. If you want to take a Python model and convert it so it can run in the web browser, we have a command line tool called the TF.js converter that will convert a TensorFlow saved model from Python so it is in the JSON format so you can run it in the web browser. There are some caveats with that, which I can get into later on if anyone's interested, but essentially this is one path you can take to then execute in the web browser. And just to be clear, you don't need to do any of this if you're trying to run in Node.js, because we can just take the files directly and run in Node.js directly if you're running on the server. The TF.js converter is only if you want to run in the web browser on the client side. So let's look at performance then. This graph shows an example for MobileNet v2, which is image recognition. And you can see when we're executing on the graphics card, in Python, we get an inference speed. So this is the time it takes to use the machine learning model of 7.98 milliseconds. In JavaScript, in Node.js, we can see that it's just 8.81 milliseconds. So this is within the margin of error of the server just having to do something else at that moment in time. There's only like a millisecond or two difference here. And what's even more interesting is that if you have a lot of pre or post processing and you write that pre or post processing in Node.js, you can actually get significant performance benefits because of a just-in-time compiler of JavaScript. And for those of you who don't know, in machine learning, typically you need to manipulate the data that you're taking from the raw sensors, and you need to transform it into a numerical format that the model can digest. And this can sometimes be a non-trivial thing to do. Maybe you need to resize the image, maybe you need to convert it to be black and white, or maybe you need to do something else to that data so the model can digest it. And if you do need to do all that pre and post processing, you can actually see a significant performance boost, as you can see here. In fact, Hugging Face, who are very famous in the machine learning world for natural language processing, for a model known as Distilbert, that is to do with natural language, just by converting to Node.js, they got a 2 times performance increase in speed by writing this in JavaScript in Node.js over the Python equivalent there. So very, very powerful, and you can get this speed up for basically free if you're using Node.js. So let's talk quickly about the client-side superpowers. These are hard or impossible to achieve on the server side. So the first thing, we talked about this very briefly earlier, is privacy. If you're running in the web browser, it means you're running on the user device. And that means none of the data is being sent to the server. This means the data is safe and it's not going anywhere. It's not being sent to a third party. And that's very good in this day and age. The second point is lower latency. Because there's no server involved, there's no 100 millisecond round trip time from the mobile device to the server and back again. I think we all know when we have had bad connectivity on our mobile devices that it's much better to run offline in those cases. And with TensorFlow.js, you can do that in the browser if you wish. Third point is lower cost. Instead of having to run machine learning servers 24/7, you can save money by not having to run those expensive graphics cards or CPUs in the cloud, and instead you can just host the model on a content delivery network, CDN, and have the model delivered to the mobile phone, which costs much less than having to run your own processor and graphics card all the time. The fourth point is interactivity. As I mentioned before, JavaScript from the whenever it was invented, has been designed to create rich content on the web, from images to 3D graphics, and nowadays even mixed reality. We've got very rich APIs for the display of content and information. And compared to other languages, JavaScript is light years ahead in terms of having mature libraries for this kind of visual stuff. And then the fifth point, reach and scale. By running in the web browser, anybody in the world can click on a link and get the machine learning for free, and they can try it live in their web browser. If you try and do this in Python, you have to understand Linux. First of all, you need to install Linux on your machine. You then have to install TensorFlow, Python, on your machine, which requires you to then install the NVIDIA graphics card drivers for the CUDA drivers, which is actually not so easy to install. And then you have to go and find the GitHub repository you want to clone, and then understand the instructions to how to use that GitHub code. So you can see the barrier to entry is much higher when working in the other situation. With TensorFlow.js in the browser, you can just send the link and it just works. And the other point to note here is that we have GPU support for over 84% of devices with WebGL. In Python TensorFlow, you can only support, I believe, NVIDIA graphics cards. TensorFlow.js, on the other hand, can run on pretty much anything that supports WebGL, such as a MacBook or anything else like that, Android, whatever it might be. Almost all devices support WebGL these days. So that was the fifth point right there. Looking at the server side, there's also some similar advantages that make it easy to use on the server-side environment. So this is in the cloud. First of all, you can take a TensorFlow save model from Python and you can use it in Node.js without any conversion. So this is really cool if you do have a machine learning team who are essentially wanting to stay using Python. That's completely fine, but it makes it easier to integrate with your web engineering team if they're using something like Node.js. Second point, it allows you to run much larger models than you can do on the client side. I believe in Chrome, each tab in the web browser can only have a maximum of 512 megabytes of RAM usage. And for some models, that might not be enough. So if you want to run models larger than that, then your only option is to run in the cloud in Node.js or Python like this. The third point, it allows you to code in one language. If you're already using JavaScript, and in fact, 67% of developers are using JavaScript these days, then it makes it much easier for you to stick to one language for your whole developer stack, from the website to the machine learning. Fourth point, there's a large NPM ecosystem. So just like JavaScript, there's lots of nice modules you can use on the server side as well. And then in terms of performance, our fifth point, as we spoke about, we have the same C bindings to TensorFlow. So you get the same acceleration on the graphics card as you do in Python. But if you have the pre and post processing written in Node.js, you can actually run even faster due to the just-in-time compiler that we spoke about. So I'm going to end with some resources here for you to get started. If there's one slide you want to screenshot today, I recommend screenshotting this one here. Essentially, we've got our website that has tons of useful information to help you get started fast. If you go to our models link here, you can find even more machine learning models. I only showed you 2 or 3 today. We've got many, many more on our website that are free to use and free to download. Go check them out. We are completely open source, which means if you are interested in contributing to TensorFlow.js, all of our code is available on GitHub and is open sourced. If you have technical questions, you can check out our Google group. And I've also got some great getting started guides and code on CodePen and Glitch, which you can simply copy and paste or fork in minutes. And you can then take that and use with some of our popular models. And I show you how you can use it with the webcam, how you can use it with images, just like you saw today. I kind of have nice commented code you can take and use yourself. If you're looking for a book, I would recommend Deep Learning with JavaScript. This was written by people on my team and people on the TensorFlow team here at Google. And it's a really robust book that takes you from zero knowledge of machine learning. It really starts at the beginning to becoming very knowledgeable in machine learning, going into things like convolutional neural networks and generative networks and all this kind of stuff to do some really fun things. So this book I recommend. It does require some knowledge of JavaScript, of course, to understand. And if you're new to JavaScript, there are plenty of courses online you can take to understand the basics. You just need to know the basics in order to understand this book. So with that, I invite you to come join our community. Here's just a few more examples of people around the world who are using TensorFlow.js for fun things. And if you search the hashtag #MadeWithTF.js on Twitter or LinkedIn, you'll find all of these and many, many more of people just like you around the world starting to use TensorFlow.js. And we are a young team. We're only 2 or 3 years old. So we're excited to see how this grows with the web community and to see what unique ways you're going to use it in. And on the subject of how people are using it, I want to end with one more inspirational piece. This guy from Tokyo in Japan, he's actually a dancer by day, and he's managed to use TensorFlow.js to make this really cool hip hop video. And you can see he's using this kind of invisibility effect, similar to the thing that I created before, but with his own unique style to make this video. So my point here is that machine learning really is now for everyone. And I'm super excited to see how TensorFlow.js can enable more than just the researchers and academics of the world, but actually see creatives, musicians, artists starting to embrace machine learning as well. And I'm super excited to be on that journey with all of you. And I hope to see what you make soon. And if you do make anything, please use this hashtag #MadeWithTF.js so we can share it and maybe even get you at one of our show and tells to talk about your project in more detail. And with that, if you want to get in touch with me, you can talk to me on Twitter or LinkedIn using the links on this slide, or just search my name online and you'll find these links as well. So with that, I invite you, if you have any questions, I'm happy to take those questions now, or of course, you can connect with me online. So thank you very much for your time, and it's a pleasure talking to you all today.
That's great. We've learned so much from you, Jason, today. Thank you very much. And there are lots of questions that we actually want to ask. So earlier on in the presentation, you were talking about this phase model where it's able to get the data points and then it will separate it. So the first question is it possible to actually take that data and transfer it to, let's say, a 3D model like Blender? Because that would make the job way easier. So is it possible to actually do that?
Yeah. So actually, so we don't have the code for this from our team. However, there are people in the community doing exactly this right now, and they are open sourcing that exact code. We've actually seen people create face masks that they can wear on their face in real time using 3D assets, using things like 3.js, which is like the web's version of Blender. Essentially, you got all the 3D graphics with 3.js, and they're able to like put face masks on themselves in real time. And one person has even used it to control a 3D model's head. So when he like looks left and right, the 3D model actually looks left and right at the same time, and all this kind of stuff. So people are experimenting with this, and if you're interested in that kind of stuff, just check out that #MadeWithTF.js hashtag on Twitter. I believe I saw that project. And it might be a little bit old now because people are pushing stuff every week. But if you just keep on scrolling, you will find that example that I'm talking about. And you can connect with that guy who created that project. He's on like Twitter and LinkedIn as well. I'm sure he's happy to talk about collaborating on that.
That's actually great. So we also have another question. And even though this is a TensorFlow.js, which is basically a Java-based session, we were able to actually manage to convince some mobile app developers to actually also join us. And they are also very curious. They saw all the stuff that you can do with this, and they are just blown away. So they wanted to know how they can also transfer that same how do I even say technology to mobile apps, so that instead of running, let's say, a web view on the mobile app, you can do it natively.
I see.
Using Flutter.
Yeah. So obviously we are a JavaScript team, so we are only interested in JavaScript. However, we do support React Native. So if you're looking for native applications that are powered by JavaScript, then TensorFlow.js runs in React Native. We've got a special version of TensorFlow.js just for React Native. And we've actually rewritten the WebGL part to run with a headless version of WebGL, so you can still get graphics acceleration in the native environment using JavaScript, which is pretty cool, actually. So if you check out our GitHub, you can find more information about our React Native implementation that has documentation and things to get started there. But if you're using Java, not JavaScript, then that's a completely different language, and we do not support that at present. You might be interested in TF Lite if you're trying to deploy to Android applications, which is the team that deals with mobile native. Yeah, I kind of compare the two and see which fits your needs best for that situation. Yeah.
Okay, that's good. So basically, any framework or platform where you can code with JavaScript, you can use the TensorFlow.js.
Anything in JavaScript can essentially be used with TensorFlow.js. Yes. So, and just to recap that, we can run in the web browser on the front end in the web browser. We can run on the back end in the cloud on the server somewhere remotely in the cloud using Node.js. We can run on Internet of Things like a Raspberry Pi via Node.js, because Raspberry Pi just runs some form of Linux, and on Linux you can install Node.js for Raspberry Pi, and that means you can run TensorFlow.js. In fact, IBM have made some cool demos where they've hooked a visual editor to code up a Raspberry Pi to recognize things as people enter the room and all this kind of stuff, which is really cool. We've got a YouTube video somewhere. We support React Native, as I mentioned before, for our native implementations on mobile. But of course, that's powered by JavaScript. It's React Native. And then we also support Electron, which is basically native applications on desktop, which are powered by JavaScript using the V8 engine. So those are the options right now for TensorFlow.js users, which is basically everything. I mean, you can essentially run everywhere if you really want to in one language, which is very powerful. Yeah.
That's great. So also, some of us would like to actually try our hands on almost everything that you just showed us and even more. So how do we get to have all these models and libraries? Although you showed us some at the end of the presentation, but then how do we get access to even more so that we can test them out and even learn how to create our own?
Yeah, I mean, I guess from my point of view, like, all the models that are built by the team are available on our website, tensorflow.org/JS. If you just Google search TensorFlow.js models, you'll also find our GitHub repository. And there's tons of models on there that have documentation to read. And they're very well written, actually. So if you're just slightly familiar with JavaScript, in a few minutes, you'll probably get the idea of what you need to do to use that model. And yeah, I encourage you to check that out. Of course, our community are also making things from time to time. And if you're just searching the tag that I mentioned, you'll probably find people who've open sourced their own code on GitHub. And we've had people convert Python models to work in JavaScript. Instead of BodyPix that does the human body segmentation that the TensorFlow team created, there's also one person who's converted a Python model that does other things like cars and cats and dogs and other things. So you can actually segment those things as well. But of course, that's a different implementation. So you have to read his documentation for that one. But yeah, I think the TensorFlow.js examples are great if you're starting out and you're new, because we've designed them to be super easy. You don't need to have any machine learning knowledge to use them. It's just like a JavaScript class. It has an API. You just call the function, you get a result. Very easy. You don't even have to worry about the format of stuff. Like, you can pass us an image-like object. So that means it could be a video, it could be a webcam stream, it could be a canvas object from the web page, it could be anything that's image-like. Whereas if you're using other people's APIs, they might request the thing to be in a very specific format. As I mentioned, all that pre-processing that needs to happen sometimes from machine learning models. Not everyone has the time to make it generic for everything. So, so in some examples, you'll find that you have to have a specific format for the data you're passing to the model. But if you read the documentation, you'll probably find out what they need. So yeah.
That's great. That's great. That's very helpful information. Also, one more thing. So let's say you are a mobile developer and you realize that you need to get your model that you have available on, let's say, Android. You want to make it available on the web. So is there any way to actually, kind of transfer that model, or whenever you want to transfer it, you have to start all over?
Yeah, so if it's written in TF Lite, there currently is no way to take a TF Lite model and push it to TensorFlow.js. However, if your original model was written in TensorFlow Python, which you then converted to TF Lite, which is actually quite popular with people these days. If you did that, then you can take your original TF Python code, export to saved model format, and you can then convert that to work in TensorFlow.js. So as long as you have it in Python, there is a path to convert to TensorFlow.js, correct? But if you only have the TF Lite model, the resulting TF Lite model, and you don't have the original code in Python or something, then there's no path to that one, unfortunately.
Okay. That's great. That's very helpful. So that's great. Before we end, we are going to pass to Hannah. She's also going to give the closing remarks and also have anything that she wants to ask, she can ask you. So Hannah, welcome.
Hey there.
Yeah, I think you have to pass it on to her again. Hannah.
Oh, Hannah, I think you are muted. So, okay, great. Welcome, Hannah.
Hi, everyone. Yes,
Hello.
it was a wonderful session. Can you all hear me?
Yep.
Yeah, sure.
Okay, great. So that was a wonderful session. And I don't know if there are any more questions. Have we answered all the questions?
So far here. So before then,
Okay.
someone else would like to know how we actually get access to the slides, or that's not possible for now.
So, get access to what, sir?
Oh yeah, so someone else wanted to know if you can get access to the slides so that they can also go
I
through.
see. This is all recorded, I believe, on your YouTube channel.
Yeah, it's recorded.
It is right now, and
Okay, so just okay.
Okay, so that's great. Thank you so much, Jason Mays, for joining us here and for taking time off your busy schedule to share this information with us. It was really awesome. And then we hope to do more projects with TensorFlow.js, and probably you see some hashtags from us also made with
that'd be great to see. Yeah, I'm looking forward to
TF.js
seeing
soon.
what everyone creates for that. Definitely.
Yeah, you definitely see some from now on. Yeah,
Awesome.
thank you so much for sharing such information with us, and thank you all for joining. And we hope you can join the subsequent sessions that we have in the future. Have a great day.
Thank you.
Yeah,
Bye-bye.
thank you, everyone. Yeah.
Bye.